Hello, welcome to this lesson. In this video, you are going to learn how to use star delta transformation to find the total resistance at terminal A and B. So let's look at how you are going to solve this question. Okay, so I already solved an example on delta star transformation. Okay, so in this case, I want us to do a star delta transformation because when you look at this question, we have a delta arrangement there and then we have a star arrangement there. So depending on the one you want to use to solve, you can use. But since I've already made a tutorial on delta star, I want us to do star delta transformation in this case. But you can also try and do delta star for this question also. Alright, so let's look at how you are going to solve this question. Okay, so you want to solve this question using a star delta transformation. Okay, so let's look at how you are going to do that. So if you look at this circuit, if you look at this connection here in the middle, you see that that is a star connection. Okay, so I'm going to change that star connection to a delta connection. Then we use that to solve the question. So let's look at how you are going to do this. So if you have a star connection and then you want to change to a delta, you are going to use these formulas. So in this case, if you want to find R1, okay, if you want to find R1, that would be equal to RB, okay, plus RC, okay, plus RB multiplying RC, okay, divided by RA, okay. So that's if you want to find R1. If you want to find R2, okay, that will also be equal to RA plus RB, okay, plus RA multiplying RB divided by RC. And then if you want to find R3, okay, that will be equal to RA, okay, plus RC, okay, plus RA multiplying RC divided by RB. Okay, so these are the formulas that you are going to use for the transformation. Okay, so now let's go back to the circuit. So I'm going to redraw this circuit in a way that it will actually look like a star connection. Okay, it looks like a star connection though, but I want to draw it in such a way that we can draw the delta connection easily. Because in this case, if I'm to try and then draw the delta connection, okay, let me try that and see. You're going to have something like this. You're going to have something like this. Okay, you're going to have something like, okay, let me do this again. Okay, and then something like this. Okay, this is what you're going to have. But I don't want it to be this way, so I'm going to redraw the circuit and then we look at it. Okay, so I have redrawn the circuit. Okay, so I have redrawn the circuit and then that's what we have here. So I have the star connection drawn with the green color and then I have the delta connection drawn with the black color. Okay, so in this case, we are going to have our RA, okay, to be equal to 6 ohms, okay, and then our RB, okay, be equal to 8 ohms, and then our RC, okay, will be equal to this 4 ohms here, right? So that'll be 4 ohms. So now let's find R1. So R1 will be equal to RB, which will be 8 plus RC, that's 8 plus 4 plus 8 times 4 divided by RA, which is what, 6, right? So let's simplify this and see what we are going to get. So I have 8 plus 4 plus 8 times 4 divided by 6. So that gave me a value of 52 on 3. So I have 52 on 3 here. Okay, so now let's find R2. So for R2, we have RA times RB, sorry, RA plus RB. Okay, so that'll be 6 plus 8, okay, plus 6 times 8 divided by RC, which is what, 4. So let's do this and see what you're going to get. So I have 6 plus 8 plus 6 times 8 divided by 4. That gave me a value of 26 ohms. Okay, let me bring the unit. So let's find R3 also. So for that one also, you're going to have RA, which will be 6, plus RC, which will be 4. So that will be plus 6 times 4 divided by RB, which is what? 8. So let's simplify that and see what you are going to get. So you have 6 plus 4 plus 6 times 4 divided by 8. That will also give us a value of 13 ohms. Okay, so now from here, let's look at how the circuit will look like. Okay, so I'm going to clean the star connection from the circuit since we don't need it anymore. So if I take out the star connection, okay, you will see that R2, okay, will be in parallel with what? This 4 ohms, and then R3 will also be in parallel with what? This 8 ohms, right? And then in all, they are all going to be in series, right? So you're going to have R2 parallel 4 ohms, right? And that will be equal to 26 parallel 4 ohms, right? And then you're going to have R3 parallel 8 ohms, right? So that will be equal to 13 parallel 8. Okay. Alright, so let's continue. So let's find R2 parallel the 4 ohms. So you're going to have 26 times 4. Okay. 26 times 4. Okay, divided by 26 plus 4, right? And then you know this will be in series with 13 times 8 divided by 13 plus 8, right? So let's simplify this and see what you're going to get. So you're going to have 26 times 4 divided by 26 plus 4, right? So that gives us a value of 52 on 15, okay, plus 13 times 8 divided by 13 plus 8. That will be 104 divided by 21. So let's do this, and we are going to have 52 divided by 15 plus 104 divided by 21. So this will give us a value of 884, okay, divided by 105 ohms. Okay, so this value here, okay, will now be in parallel with the R1, right? And we know R1 to be 52 on 3. Okay, so let's do the calculation. Let me free up some space here. Okay, so we are going to have 52 on 3, okay, times 884 on 105, right? This divided by 52 on 3, okay, plus 884 on 105, right? So let's simplify this. So in the first bracket, you have 52 on 3 times 884 on 105, right? So let's see what you're going to get. I got 145.9, okay, divided by, let's see for the second bracket too, we have 552 on 3 plus 884 on 105. That also gave me a value of 25.75. So now let's do a division. So you have 145.9 divided by 25.75. So that gave me a value of 5.67 ohms. Okay, so we're going to add this to the 4 because it is going to be in series with the 4. So we're going to have 4 plus 5.67 ohms. Let's see what you're going to get. So that gives us a value of 9.67 ohms. So this will be the total resistance at terminal A and B.